Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Teal Rectangularity by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. Any 3 digits along a teal modular line have different residues. Again, I don't know if residue is a technical term that other English countries uses for this, but we usually call it remainders. In the US. I don't know if it's the same in other English-speaking countries. But residues or remainders, which is what we usually use in the US, modulo 3. That means when divided by 3, what is the remainder? You could have, and there are 3 different sets. You could have 1 modulo 3, which is 1 digit from 1, 4, and 7, which because if you divide by 3, you have a remainder of 1. 1 from 2, 5, and 8, which is if you divide by 3, you get a remainder of 2. And 1 from 3, 6, and 9, which when you divide by 3, you have a remainder of 0. So that would equate to the sets. So along any 3 adjacent digits along a teal modular line has to be in a different set modulo 3. You can have 1 from 0 modulo 3, you have to have 1 from 1 modulo 3, and you have to have 1 from 2 modulo 3 for every 3 digits in this modular set. So for example, you could have something like, say, 3 here, 8, and 1. And this would be valid because along this set of 3 unique digits, you have 1 from 0 modulo 3, which is the 3, 1 from 1 modulo 3, which is the 1, and 1 from 2 modulo 3, which would be the 8 in this case. So that's how modular lines work. And we have, within a cage, digits must not repeat, and they sum to the small number in the top left corner of the cage. So, for example, if this were, say, a 1, this would have to be 8 to add up to 9. Because these 2 digits must add up to 9 because of the 9 in the top left corner, and those are the only 2 digits in the cage, so those are the only 2 digits which sum up to that sum. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, how do we attack this? Okay. In row 3 and 4, we have 7 digits on modular lines. Same with rows 6 and 7, and same with column 3 and 4, and column 6 and 7 here. Okay. We know these 2 digits, every 3rd digit on a modular line must be the same set. And the reason why we know that is, take a look at these 3 digits here. Basically, let's mark them as different sets, because obviously you have to have 3 different sets for 3 adjacent digits on these lines. Well, what digits are we losing from this? We're losing a yellow set digit from here. So that means for the third digit next to, for this set of 3 digits, we have to have a yellow digit here. So every third digit is going to be the same set. So these are guaranteed to be the same set. These are guaranteed to be the same set. These are guaranteed to be the same set. And so those are the... So these, and these are all guaranteed to be the same set. Okay. To add up to 7 to be the same set, 1 and 6 doesn't work. 1 is 1 modulo 0, 3, and 6 is 0 modulo 3. Same with 3 and 4. You have 0 and 3, so this must be a 2-5 pair here. So this is 2-5 pair, which is 2 modulo 3 to add up to 15. 7 and 8 don't work. It must be 6 and 9. So that's 0 modulo 3. These are the same set. It cannot be 2, 6. That's 0 modulo 3, 2 modulo 3. Cannot be 3, 5. That's again 0 modulo 3 and 2 modulo 3. So this has to be 1, 7 as a pair. And what about 2 digits adding up to 9? 1 and 8 is 1 modulo 3, 2 modulo 3. 2 and 7 is 2 modulo 3 and 1 modulo 3. 3 and 6 works, and 4 and 5 doesn't work. So this must be a 3-6 pair here. So we have 3 and 6. Okay. What does that mean? It means in row 4, we are guaranteed one of these digits is going to be red. And we have 2 more reds here. That means the rest of these digits in row 4 cannot be red. So some combination of yellow and blue, which means these both have to be red. And so this is a combination of blue and yellow. We have something similar in row 6. We have 2 yellows here. There's guaranteed to be a yellow here, so this cannot be yellow, yellow here. This is red and blue as a pair. That leaves these both as yellow here. So this is yellow, yellow, and this is blue, red as a pair. Same with column 6 and column 4. So note, one of these is guaranteed to be blue, so this cannot be blue. Therefore, this is a red-yellow pair. Where's the blue? It has to be blue, blue here. This is red, yellow as a pair. We are guaranteed, because of that, we are guaranteed another red here. That means these digits cannot be red, so this is also a blue-yellow pair in row 3. And we should have something similar for row 7. This cannot be yellow because one of these is yellow. We have a yellow here. We have 2 yellows here. So this must be a red-blue pair here. So we have guaranteed 1 red and 1 blue here, and this is 2 blues. Because one of these is blue here, and that's this one. One of these 2 has to be blue because this is a red-blue pair. Therefore, we are guaranteed red and blue here. This is 1 blue here guaranteed, 2 blues here guaranteed, which means this can't be blue, so this is red, which makes that blue there. Red, it has to be, we're losing a blue for this set of 3 digits here, so this must be blue there, which makes that red there. So this is red for that situation. We have a red-yellow pair here, which means we have 3 reds in this box in box 1, so this can't be red, it's yellow, which makes this red here. So since this is yellow, this must be red here, that must be yellow there. Similar situation for this set here. We have 3 blues We have 3 reds here. Hold on. Right, these can't be blue here. So this is a red because one of these is blue and we have 2 blues here. So these can't be blue. It's a red-yellow pair, which means blue has to be one of these two. So one of these two is blue and yellow because only one out of these is blue. So we have 3 blues in box 3, so this can't be blue. It's yellow, which makes this blue. That makes this blue here, and this is yellow. Okay. And we have the same thing in column 7. We have this as a red-yellow pair. That means 1 each, so this must be a red-yellow pair here. That's 3 yellows in box 9, so this can't be yellow. That's red, which makes this yellow there. Red means this has to be yellow there, which makes that red. In box 5, we have 3 yellows and 3 reds, which eliminates yellow and red in the rest of the box. That leaves that as blue. Okay. This has 3 reds accounted for in box 1. We have 1 yellow here, 1 yellow here, and 1 yellow here, which means that's 3 yellows accounted for in box 1, so these are both blue. Interesting. So we should have something similar for each of these situations. We have red and yellow there. That's a yellow here, and a yellow here. That's 3 yellows, so these are 2 reds. We have 2 yellows here, 1 yellow here. Red, red, and red, so this is 2 blues. We have 1 blue, 2, 3 blues there. Red, red, and red, which makes that 2 yellows. So that's interesting. We have 3 blues in column 7, so the rest have to be red and yellow. We have 3 blues in column 4, so this is also red, yellow. So this must be 1 of each here, 1 of each there. So that's red, red accounted for. So this must be a blue-yellow pair. But this can't be blue because of the 3 blues in the row. So this is yellow, which makes this blue. Okay. This must be not red. It's yellow and blue as a pair. This cannot be yellow, so it's red and blue as a pair. Similarly, in box 8, we have to have a blue-yellow pair, blue-red pair here now, because we have 3 yellows. And blue can't be here because of the 3 blues in the row. So this is red, that's blue. Remaining digits here are red and yellow. We have red and yellow here. One of these is guaranteed to be red here, and we have 2 more reds here, so this can't be red, which means this can't be yellow. And similarly, we have 2 yellows here, and one of these has to be yellow, so this can't be yellow here, it's red. That means this can't be red, it's yellow. Okay. So this has to be 1 or 4 here to add up to 9. Because 1 would be with 3 or 5, or 2 or 6. And 4 would be with 2 or 3. And 7 doesn't work at all. So this is 2, 3, 5, or 6 here. 2, 3, 5, or 6 there. 6, 9 as a pair there. This can't be 2 or 5 because of the 2, 5 pair in the row, so this is 8. This has to be 4 because of the 1, 7 pair in the row. This has to be 3 because of the 6, 9 pair in the column. That makes this 6, which makes that 3 there. That leaves 9 remaining in as the last 0 mod 3 in box 2. That means this cannot have a 9 to add up to 21. So it must be 6, 7, and 8. So this is 6, which makes this a 7, 8 pair remaining. That eliminates 7 and 8 remaining in the rest of the row. And this can't be 6. So if this is blue, it must be 3. And this can't be 3 either. So if this is blue, it must be 6. That's not that helpful. 9 is here. Where is 9 in box 5? Cannot be here. So 9 in box 5 has to be here. So this 9, which makes that 6, and that leaves a 6 there. This is then 3 or 9. We have 3 or 9 there, and 3 or 9 there. 3 and 6 eliminate 3 and 6 there, so that's 9, which means this can't be 6 or 9. It's 3. So, to add up to 15, this is 6 or 9 here. We don't know which. Excuse me. Okay. So one of these digits here. So we have 3 and 6 here, which means 9 has to be the 0 mod 3 digit here. Which means this can't be 9, that's 3. That leaves this as a 6, 9 pair, and then one of these is a 3 guaranteed. 3 eliminates 3 there, so it's 9, which eliminates 9 there. That's 3. This becomes a 6, 9 pair here. We have a guaranteed 3 in one of these two. That means 3 has to be one of those two. Okay. Remaining digits of row 2 are 1 through 5. And 3 obviously cannot be any of those. um... Hmm. Okay. This can't be 4 because of 4 in the column. One of these is guaranteed to be a 4. Which means this can't be 4, so this is 1 or 7 also. This cannot be red. So this cannot have 1 or 4 here. So we're guaranteed a 3 here, and the other one's 2 or 5. One of these is guaranteed then to be 8. We don't know which. And this could be 1, 4, or 7. It's not really that restrictive. This cannot be 8, so this is 2 or 5. It's obviously 2, 5, or 8, as are these two. What do these add up to? So we have 9 with 1 or 5, or 9 with 2 or 4, or 6 with 1 and 8, 2 or 7, or 4 or 5. So that's pretty broad. We have one. Oh, this is cannot be 2 or 5. It's 1 or 4. Hmm. Um. Can this ever be 5? The answer is no. If this is 5, that would force this to be 1 and 3 to add up to 9. But we can't have 3 be here. So this cannot be 5. Hmm. This has to be 2, 5, or 8. 1 or 7 here. 1, 4, or 7 there. 1, 4, or 7 there. You could have 8 with 1, 3 as possibility. So that would be 3. That would be 1. 5. That would mean the remaining 2 must add up to 12 minus 5, which is 7. So it's 1, 6. Or 3 and 4. Or you could have 2 here, which means the remaining 2 digits must add up to 10. So you could have 1 and 9. 3 and 7. Or 4 and 6. Pretty broad. um, hmm. What else do we have? So this digit cannot be the same as either of these, so it must be the same as that. Let's mark it as A. So this must be 3 and A as a pair. This is B, so B has to be one of those 3. B cannot be here. B cannot be here, because that's 7 or 8, so B has to be one of those 2. That means B cannot be there. B is one of those 2. Interesting. So this cannot be B, and it cannot be A, because this A means it can't be here. It's one of those 2. And B cannot be here because of B in the column. So this cannot be yellow, which means this is red. Which means we have a red pair in row 2, so this can't be red here. That leaves this as B there, because it cannot be 8. So this is 2 yellows there. This can't be yellow. That's red. One of these is guaranteed to be red. This is a red-yellow pair, so this can't be red. It's yellow. So this has to be B, which means this can't be B. That's 8. So we know 8 has to be one of these 2 digits in row 3. This can't be B, but it could be A. I don't know. A is one of these 3, though. So this is an A-B pair here. We're just not sure which. Okay. Hmm. Interesting. That was actually very interesting. Do we have something similar with the 1/7s? I don't feel like it. Maybe. Maybe. Let's make this Z and Y. Z can't be here. So Z has to be one of these two. That means this can't be Z. It cannot be Y, but we don't know if the X can be there. 4 could potentially be there. So the reason why this worked is because we knew this added up. This had to be 6, 7, 8 without the 9. But the problem is this is pretty open. So we don't have necessarily that same restriction. That's the reason why this worked, because we knew that this couldn't be 8 because of the 6, 7, 8 triplet here, and it couldn't be both B or A, because A had to be here and B had to be here. So that left that as 1, 4. 8 cannot be here. This is cannot be 4. It's 1 or 7. Huh. Oh, where is 9 in row 4? It cannot be here because of 9 in the box. Can't be here because of the cage, so it has to be here. Which means that's a blue, which means neither of these are blues. So these are both yellow, which means that can't be yellow there. It's blue, which makes that a 3. So we have 3 here. This is A, that's B. This has to be a 9, which means one of these remaining is a 6. That means this cannot be 6 here. We have to have a 6 be one of these two. 9 eliminates 9 there, so that's 6 and 9. Therefore, this can no longer be 6, whereas the 6 in box, or specifically, yeah, box 4, cannot be here. It has to be here, which makes that the blue. That means this can't be blue here because of the blue-red pair. This can't be 3, so this is no longer blue. That's red, which makes that the blue there. So we can delete that. This is 3. That's 6. No more 6 here. It's 1, 5 or 2, 4. We don't know which. This is red here. Blue there. 3 has to be one of these two. I'm not sure which. Hmm. Z. We know 9 is here, and Z is here. So this cannot be 4. Actually, we don't know. It could be 6 or 9. But we know the Z is here, so it's 1 or 7. And we have 6 or 9 here. So how does this add up? We could have 1, 8, 3. 5 with 4, 6. No, 5 with 3. Hold on. 5 with 1, 6. It cannot be 3, 4. And 2 with 1, 9, 3, 7, or 4, 6. Any of those work. So this cannot be Z, or Z is red. So Y is one of these 3. That's not too helpful. um... Oh, this can't be 8 here. This can't be 8 here. So where's the 8? It has to be here. That means this cannot be A. It's B. 8 eliminates 8 here. So where's 8 in box 5? It has to be here. That leaves A being here, so this is A there. This is 8. You can have A or B here. 8 is one of these two. We don't know which one of these is which. This is 2 of 5. We have 2 of 5 there. So we know this is 8. One of these two is 8 because this can't be 8 here because of 8 in a row. So this cannot be 8. Where is 8 in row 7? It has to be here. So that's 8. This can't be 8 here. 8 has to be one of these two digits there. So we have 8, and this must be B here. A has to be one of those two. Huh. Where is the 7 in column 2? It cannot be here. It can only be one of these 3 digits, which means this cannot be 7 here in box 7, because we have a guaranteed 7 in one of these 3 cells. And this can't be 4 because of 4 in the column, so this is 1. Which makes this 7. That eliminates 7 there. It's a 1-4 pair here, which eliminates 1 and 4 in the rest of the row, so this can't be 1. It's 7. That eliminates 7 being there, so that's 8, which is the yellow cell. So we have 3 yellows here. That means this can't be yellow. It's red. So this can't be B. This has to be non-yellow. It's red, which means this can't be red. That's yellow. So this has to be 7, which makes this an 8. So there's no 7 here, no 7 along this cage. So this is B, which makes this A. That means this is 2, 5 as a pair. Where that eliminates 2, 5 in the rest of the column. So this cannot be 2 or 5. We are guaranteed an 8 here. 7 is here. That leaves us as 1 and 4. This is A, so this is B, which makes this A, which makes that B. Where's A in box 9? It has to be one of those two now, which means this can't be A, that's B, which makes this A. So we have all the B's. B can't be here. So this is B there, and it's 2 and 5. So we have, I think, all the B's. So B has to be the last yellow digit there. This could still be 4 here, so we don't have any information there. This has to be a 1-7 pair here because of 4 in the box. That means this cannot be 1, it's 4, which makes this can't be 4, it's 1. So B has to be a 5. So we can remove 5s from all of these. So B's are there. A's then have to be 2s. So where we don't know exactly where the 2 is, we'll set those to 2, or we'll remove those. So it's 2 and 5. So this becomes a 9-2 pair here remaining in row 3. This is 1-4 as a pair. That eliminates 1 and 4 in the rest of the column. No more 5 here, no more 1 here. Remaining digits of column, so remaining digits of column 1 are 5 and 8. Remaining digits of column 2 are 2, 4, and 7. So no 2 there, obviously. We don't have very much information about why. Remaining digits of column 4 are 1, 4, 7, 8. We have 1, 4, or it cannot be 7 here because of 7 in the column. So the 1, 4 pair remaining in column 5. Column 6, we have 1, 4, 7, or 5, with a 5 guaranteed as one of those 2 digits. We have 3 with 6 or 9 there. Remaining digits of row 4 are 2 and 6. Okay, that's interesting. Remaining digits of column 7, we have 1, 4, 7, and 2. Obviously no 1 or 2 there. So, this is guaranteed to be 5. That means to add up together to 12, the remaining digits are 12 minus 5, which is 7. So there's no 9 here. It cannot be 3, 4 as a pair, so it has to be 1 and 6. So we have 1 here and 6 here, which means this cannot be blue. It's red, which means it can't be red. That's blue. This is not red. That's blue, which means this can't be blue. It's red. So Z has to be a 7. That leaves this as a 9. This can no longer be 1 and 5 because of the 5s in the column, so this must be 2 and 4. Therefore, this is not red, it's yellow. This is not yellow, it's red. No red there, it's yellow. No yellow there, it's red. 1, 5, and 6, that leaves this as a 3. 6 eliminates 6 there, so this cannot be blue. No yellow there. Blue, 2 eliminates 2 there, so this is not yellow, not blue. So these are 2 and 2. That eliminates 2 there, so it's 9. 2 eliminates 2 there, 6. 1 eliminates 1 there, it's 4. No 6 or 9, it's 3, which leaves that as a 9. This is Z, so Z is a 7. That eliminates 7 here, so that's 4, which makes that 7. This is 2, which makes this 4. 2 and 4 add up to 15 with 9. And 9 eliminates 9 there, so it's 6. This can't be 4 or 7. We also know 1 is here. 1 eliminates 1 here, so it's 4 and 1. 4 eliminates 4 here, so it's 1 and 4. 1 eliminates 1 here, so that's 4. This can't be 1 or 4, it's 7. 7 eliminates 7 here, so it's 1 and 7. 4 eliminates 4 here, so it's 1. So this can't be 1, 4, or 7, which makes this a 5 and is not red, so it's yellow. And we have 3 yellows already in row 8. So this can't be yellow, it's red. This can't be red, it's yellow. We have 3 yellows here. This can't be yellow, it's red, which is a 7. That's 5. That's 1. Which makes this a 2 here. That leaves that as 8, which makes this 5, which makes that 8. And that's a solution. Pretty cool, actually. It was interesting how those modular lines interacted. And how the cages restricted certain aspects of those modular lines, which was interesting. Yeah, just a really nice puzzle. It flowed very well throughout, and yeah, just a nice puzzle throughout. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.